Good morning. So before you guys can actually start this video or this Edpuzzle, I need to make sure you all have at least a calculator that has a couple of types or options for functions. What you're going to be looking for, let me zoom in on my calculator here. Okay, you can do this. It would be ideal if you had an e to the x, okay, function key. That would be the ideal. That's going to give you the best possible answer for any question we might have on population growth. The other option is this key that looks a little bit like a caret, okay, the raised to. And then of course, some calculators just have an x to the y key, okay? So any one of these options will work. This will work, this will work, and this will work, okay? These are the three options you want to have on your calculator. If you don't have it, you might as well end this video now and go find a calculator that has it, and then you can pick this up, because I am going to have a couple of questions at the end that I'm going to ask you to solve. Alright, so let's get this going. I'm going to zoom back out a little bit, move my camera over. So what we want to do is we want to be able to utilize this equation on a test or a quiz, and it's not at all hard. Okay, so I'm going to write that down here on my piece of paper. So we want to find the population at time t, and to do so we want to go ahead and use the formula, the starting population, the n naught population, times e raised to the rt, okay, which of course r is the growth rate and t is going to be the time. So let me move this out of the way for the moment. And here's my equation that I just wrote down. So as a quick example, let's just say that I want to know what the population is at, say, 5 years. Okay, so t is going to be equal to 5. The growth rate is going to be 0.5, 0.5. And then the starting population is going to be 200. So n naught is equal to 200. Okay. Now to run that, so essentially what I'm asking you to do is solve the final population at time t is equal to 200 times e times raised to 0.5 times, what did I say, 5 years, 5. Okay. So that's the equation we want to run right there. And keep in mind that if you don't have a calculator with e on it, we're going to substitute e is roughly equal to 2.72. Okay? So, therefore, we could do this, and at t is equal to 200, our starting population, times 2.72, if you don't have the e key, times 0.5 raised to, times 5 for 5 years. Okay? So on my calculator, let me move this over, and I'm going to zoom in a little bit. Okay? What I would do is I would simply take, I should zoom out one so you can actually see all the keystrokes, and pull that down. Okay, so I'm going to take 200 times, in my case I'm going to go ahead and use the e key, the second function e, okay, and it's going to be 0.5 times 5, and I'm going to close off the parentheses, and it's equal to, okay, and I'll write that number down. It's going to be equal to 2436.5. Okay? Now let's compare that. I'm going to clear it. If you did not have the e key, okay, you can use the y to the x, or you can use the caret thing here. Okay? So let's go ahead and turn this guy on again. And we're going to go 200 times 2.72 raised to, open parentheses, 0.5 times 5, close parentheses, equals and we get roughly the same number, but not exact because 2.72 is an approximation. I'll round that to 0.4. Okay, and last I'll do it on this calculator here using the function x raised to the y. It's going to be 200 times 2.72 raised to, open parentheses, 0.5 times 5, close the parentheses, equal. And you see, once again, we get in this case, we get the exact same number we did on the calculator by using either the caret or this key right here. Okay? And lastly, let's compare it to what we would have seen if we did it on the graph. We'll open this up. We're going to set our starting population at 200. We want to raise it, the population growth to 0.5, and let's set time to 5 years, and you can see that we have, there it is, the population 2436, and if I go ahead now and pull this down, you can see that was the number that I had recorded here by using the natural log on my keyboard. Okay, so let's just do one more. I'm going to pause it, I'll set it up, and then I'm going to give you like 3 to solve yourself, and I will see you soon. And if you hear some funny noises, it's because somebody's doing siding on my house, and you can see the building I'm in is under construction, and they're working on it right now. But here's one I want you to do by yourself, and then I'll show you my answer. So let's say the starting population is 1,000, and then our growth rate is going to be 1.6. We run it for 10 years. Okay? So here's your equation. Oops, you can't quite see it all. Hold on 1 second. Okay, so it's going to be 1,000 times e, or 2.72 raised to 1.6 times 10. Okay, I'm going to pause this, and you guys calculate it. I would say you should pause yours, give me an answer, and let's see if we get the same answer. I'll be right back. Okay, so hopefully you came up with an answer, and it was probably a shockingly huge number. So you hopefully doubted yourself, but you should have been right, okay, if you got a shockingly huge number. If you had a calculator with a natural log, or E, you came up with this, oh my gosh, what is that, hundreds, thousands, millions, 88 billion, okay? And if you use 2.72 and use the caret function or the x to the y function or y to the x function, you would have come up with a similar number, but not the same. And of course, if we compare it to what we would have seen on the web-based assignment, you see that we would have had a similar number. Okay? So that being said, if you got that, you got the system down, and you're going to be fine. I'm going to give you like 2 theoreticals, and you'll have to give me an answer, maybe 3, on the Edpuzzle, and we'll call it a day. So give me a moment to get them down, and I'll see you soon. Okay, so your first one is basically looking at the human population and what it'll be like when you're my age. Okay, so we have roughly 7.5 billion planets on the people on the planet. The growth rate for the human population is about 1.1%, so we have to convert that into a decimal value. And 40 years would put you guys at 55 or something like that, 56. So tell me what the population of the planet will be at its current growth rate. So I'm going to pause it. You're going to see the little Edpuzzle thing pop up and answer the question, and I'm going to give you another one. Okay, let's just keep this simple. We'll just do 2. So the second one, we're starting out with a population of only 10, but we have a really pretty high growth rate of 2.0. And let's run it for 5 years. Okay, so go ahead and do the calculation and choose the answer which is the best represented, and I will see you again soon. Have a good one.